Persona Plug, Personalized LLMs, proposes a novel approach to tailoring LLM outputs to individual user preferences. Let's explore the technical details. What are the main challenges in personalizing LLMs?
The main challenge is balancing the need for personalized outputs with the computational cost of training and deploying LLMs. Fine-tuning a separate LLM for each user is computationally expensive, while simply feeding all user history into the LLM can be inefficient due to input length limitations. Retrieval-based methods, which select relevant user behaviors as demonstrations, can be unreliable in capturing the user's overall style and preferences.
So this paper proposes a new solution called Persona Plug, P-Plug. Can you explain how P-Plug works?
P-Plug introduces a lightweight plug-in module called the User Embedder. This module encodes a user's historical behaviors into a single user-specific embedding. This embedding is then attached to the task input, allowing the LLM to understand and capture the user's habits and preferences without requiring any parameter tuning.
That's interesting. How does the User Embedder module work?
The User Embedder consists of two main components: a user behavior encoder and an input-aware personal aggregator. The encoder represents each historical behavior as a dense vector, while the aggregator synthesizes these vectors into a single personal embedding based on their relevance to the current task input.
So the personal embedding is essentially a summary of the user's historical behavior weighted by its relevance to the current task. How does this embedding help personalize the LLM's output?
By attaching the personal embedding to the task input, the LLM can better understand the user's preferences and generate more tailored responses. For example, if a user frequently uses formal language in their historical interactions, the LLM will be more likely to generate formal responses in the future.
This sounds like a more efficient and effective approach than fine-tuning or retrieval-based methods. What are the key advantages of P-Plug?
P-Plug offers several advantages. First, it's a plug-and-play approach, meaning it doesn't require any modifications to the LLM's structure or parameters. Second, it's computationally efficient, as it only requires training a lightweight user embedder module. Third, it can capture the user's overall style and preferences, leading to more consistent and personalized outputs.
Can you elaborate on the computational efficiency of P-Plug?
The user embedder module is significantly smaller than the LLM itself, typically introducing only a small fraction of additional parameters. This makes it much more efficient to train and deploy compared to fine-tuning methods, which require training the entire LLM for each user.
How does P-Plug compare to retrieval-based methods in terms of capturing user preferences?
Retrieval-based methods focus on selecting the most relevant historical behaviors, which can be effective for specific tasks, but may not capture the user's overall style. P-Plug, on the other hand, aggregates all historical behaviors into a single embedding, providing a more comprehensive representation of the user's preferences.
So P-Plug is essentially a way to encode the user's persona into a single embedding. How does this approach address the limitations of previous methods?
P-Plug addresses the limitations of previous methods by providing a more efficient and effective way to capture and represent user preferences. It avoids the computational cost of fine-tuning and the potential for inconsistency in retrieval-based methods.
The paper mentions that P-Plug can be optimized in an end-to-end manner. Can you explain what that means?
End-to-end optimization means that the entire model, including the user embedder and the LLM, is trained jointly to minimize the next token prediction loss. This allows the model to learn the optimal parameters for both the user embedder and the LLM, leading to improved performance.
The paper also mentions an instruction embedding. What is the purpose of this embedding?
The instruction embedding is a trainable vector that helps the LLM understand the specific task it's being asked to perform. For example, if the task is to generate a news headline, the instruction embedding will help the LLM generate outputs that are consistent with the characteristics of news headlines.
So the instruction embedding helps the LLM understand the task, while the personal embedding helps the LLM understand the user. How do these two embeddings work together?
The instruction embedding and the personal embedding are both incorporated into the LLM's input, allowing the model to generate outputs that are both task-appropriate and user-specific.
To wrap up, can you summarize the key contributions of this paper?
This paper proposes a novel, personalized LLM model called P-Plug, which uses a lightweight user embedder module to capture user preferences and guide the LLM in generating tailored outputs. P-Plug is computationally efficient, plug and play, and can capture the user's overall style and preferences, leading to improved personalization performance.
This was a fascinating discussion on the technical aspects of P-Plug. Thank you for your insights.